Hi there, I'm Hao. This is just another video of me solving random code problems. So let's begin. You're given a two head of the two sorted linked lists, list one and list two. Merge the two lists into one sorted list and return the head of the merged linked list. So it is very similar to the merge step if we are doing a merge sort, right? When we have two sorted array. So we can just have like two pointer pointing at each of the list. And then we just keep adding it to the resulting list as we iterate through list one and list two. So let's say we can add one here, right? Because one is smaller than or equal to one. And if we have one and two, we just compare the two and just add the smaller one, right? And then just keep incrementing like this, two, right? And now we add three, because three is smaller than four. Right now we add four, right? And if the let's say this is one and this is L2. And if one of the linked lists ran out of elements, like we can just like concatenate L2 here, right? Pointing to L2. Let's say we have like more nodes after, but it doesn't matter. We can just take the next to whatever remaining here. So we can create a new list to do that, or we can also use recursion. If we use recursion, then we also do the same thing. We would compare, right? And then reassign the next pointer like this, right? Like this, and then like this. So both methods will give us the same space complexity of ON. For the recursion, even though we don't create any new list node, but we need to use the call stack. So the space complexity would be ON, and the time complexity would be the same for both methods, would be O of so if the length of list one is M and the length of list two is N, it will be M plus N. Also be more specific, it will be the minimum of M and N, right? Because as long as we reach the end of either list, we will stop and concatenate whatever left over into our resulting list. So let's go ahead and code this up. I will implement the using recursion. So we have what is our base case? Our base case is when the list one is empty, right? It's null. If we don't have a list one, then we can just return list two and vice versa. So if not list two, then we can just return list one, and then we can compare, right? If list one dot value is less than list two dot value, then we can return list one, right? And then we can set the list one dot next equal to merge to list of list one dot next and list two. Else we do the same thing, but for list two. So list two dot next would be equal to this one, comma list two dot next, and we're gonna return list two. Right? If the value at this one is smaller, then we're gonna set the list one dot next pointer to whatever results we have here by calling the sublist list one. Right? We calling list one dot next, which is one step closer to the base case. And yeah, we return the list one at the end. So let's give it a try. Submit. And it worked. We can also use an iterative solution for this. We can create a head of new list node, right? And we can have a current pointer pointing to the head. and y list one and list two. So if list one value is smaller than list two value, then we can set the current left equal to list one. We can reset list one. Uh, else something, but for list two, right? Then we want to update our current pointer. Right? And after the while loop, if either so the breaking condition for the while loop is where list one is empty, is null, or list two is null, right? So we can just concatenate whatever left over if either list is null. So we can do clear that left is equal to list one or list two, and we can return other left because the first node is just the dummy node. And thank you for watching.